Okay, we're going to take a look at some of the information that we covered in lesson 3.3. Beginning with the first I can statement. I can find the sum of interior angle measures. You'll notice there's a key idea concept box on page 120 in your textbook that talks about the interior angle measures of a polygon. It says the sum S of the interior angle measures of a polygon with n sides is as follows. S equals n minus 2 times 180 degrees. You might recall that in class we did an activity in your practice journal. In fact, I'll rewind our smartboard presentation here so that you could take a look, that talked about and explored the interior angles of a polygon. And you were asked to take these figures and to cut them into triangles. And so when you took a look at a polygon, which, by the way, is a many-sided figure. The prefix poly means many, gon means side. So the definition of a polygon is a figure with sides. So something like a circle does not have sides. It is not considered a polygon. However, these examples that you see on the screen right now are, in fact, polygons. And if I take this figure here in figure B, and I take a look at how many sides it has. This has 1, 2, 3, 4, 5 sides. It would be considered a pentagon. So if we think about how many triangles can we divide this up into, this is what you did in class in the practice journal, if you were in class for this. We divided this into triangles, and we looked at what's the fewest number of triangles we can create in a pentagon. So as you can see here, I've cut this into how many triangles. So here's one triangle, here's a second, and here's a third. So my 5-sided figure can be divided up into 3 triangles. A 6-sided figure, if we continue, we look at part C. This has 1, 2, 3, 4, 5, 6 sides. So that polygon is a 6-sided figure, or a hexagon, can actually be divided into 4 triangles. And you could cut these in different ways to create your 4 triangles. But the main idea here, and what we discovered when we explored this activity in your practice journal, is that the number of triangles that you can divide your polygon into is always 2 smaller or 2 fewer than the number of sides. In a 5-sided figure in question figure B, we had 3 triangles. In a 6-sided figure in question C, we had 4 triangles. So if we come back to the formula, that's where this formula comes from. So it's important that we take time to try to understand what exactly does that mean. So this n minus 2, n is referencing the number, that's pound sign for number, not necessarily hashtag, number of sides. So n represents the number of sides of your figure. So if we take a look at example 1, and this is still on page 120 in your textbook, it says find the sum of the interior angle measures of the school crossing sign. So for all problems like this, we need to use that formula, where we take the number of sides, we subtract 2, and we multiply that by 180 degrees. So if I take a look at this street sign, the first thing I have to do is take note of how many sides are there. So as I take a look at these, there are a total of 5 sides to this figure. So that number is what I'm going to plug in for the number of sides, because this is a 5-sided figure. So I'm going to do 5 minus 2 and multiply that by 180. So what is 5 minus 2? Simple question, right? 5 minus 2 is 3. You multiply that by 180, and you get a total of 540 degrees. What that means is the sum of all of the interior angles, interior, remember, means inside, all of the interior angles of this pentagon, the sum of all of these sides here adds up to 540 degrees. So I might not know exactly what those angles are, but they have a sum of 540 degrees. And I calculated that using this formula that we discovered in our activity in the practice journal. The 180 degrees, it's important that we haven't talked about this yet, but where does that come from? Where do you get that 180 degrees exactly? Like, what does that mean? So we know that the sum of all of the interior angles of a triangle adds up to 180 degrees. So because a pentagon can be cut into 3 triangles, for example, I could cut it into, here's one triangle, and then if I cut diagonally here, here's a second triangle, here's a third. So each of those triangles has 180 degrees. So there's 180, there's 180, there's 180. So 3 times 180 is 540. And when you do these problems, you're not going to draw these pictures, you're not going to slice it up into triangles. It's not necessarily to do all that work. But it's important that you understand that's how this formula here that we're taking a look at, that's where this was discovered, was by mathematicians manipulating figures in this way. Okay? So if we take a look at some of these on your own problems, which are also on page 120 in your textbook, every time you do one of these questions, and you think about the sum of the interior angle measures of the polygon, you first need to know the number of sides. So if I take a look at question 1, how many sides? 1, 2, 3, 4, 5, 6, 7. Okay? So we have a 7-sided figure. So the only thing that's different is when I use my formula, n minus 2, and I multiply 180, n minus 2 is 5. Right? There were 7 sides. Okay, so I should probably back up here in my work. So I have 7 sides minus 2 times 180. Okay, so I'm going to multiply 5 times 180. So I've got to take a minute to think about, well, what exactly is 5 times 180? And honestly, that's not something I know off the top of my head. So I use my calculator, 5 times 180 degrees. So that's 900. Right? So that tells me the sum of all of the interior angles of that spider web there is 900 degrees. And that's the answer that they're looking for. Okay? So that takes care of the first I can statement that we're talking about here today. Okay, the I can statement said, I can find the sum of the interior angle measures. The second I can statement we're going to take a look at, this is an example 2, which is on the next page in your textbook, page 121, finding an interior angle measure of a polygon. So here I've got a missing angle measurement. Okay, I'm being asked to find what is the value of that angle right there. Well, similar to what we've done with triangles, right? We knew triangles always added up to 180 degrees. Well, that's not true for this figure, but I can figure out what the sum is supposed to be. What is it supposed to add up to? So first I want to figure out what is the sum of all of the angles. So that's the first thing I'm going to take a look at, and I'm going to use that formula, the number of sides minus 2 multiplied by 180. That will tell me the total, okay? So if I take a look at this, I can count the sides, 1, 2, 3, 4, 5, 6, and 7, a 7-sided figure. We actually just did this problem just a second ago, okay, but it was a different 7-sided figure. 7 minus 2 times 180, okay, so that means 7 minus 2 is 5. When you multiply that by 180, you get a sum of 900 degrees, okay? You might need to use your calculator to tally that up again. I'm just remembering that exact problem from a few seconds ago. Okay, but that's not actually my answer this time, because now they're asking me to find what is the value of x. What is the value of that missing angle? So in order to figure that out, I've got to add up all of these other angles together. Okay, so that's the second thing I've got to do, is I have to figure out what is, if I add all these angles, if I add 140 plus 145 plus 115 plus 120 plus 130 plus 128, if I add all of those values together, what am I going to get? So follow along with your calculator. Type these in: 140 plus 145 plus 115 plus 120 plus 130 plus 128. Okay, and when you add all of those together, what do you get? Okay, you get 778. So we know that all of these added together is 778. Okay? Well, I know 778 plus whatever x is has to equal 900 degrees. So in order for me to figure out what x is, I have to subtract that 778 from both sides of my equation. Okay, so I'm going to subtract 778 from 900. Okay? When you do that, you get an answer of 112 degrees. So hopefully, again, you're following on with your calculator. 900 minus 778 is 120 degrees. All right, so if we take a look at question number 5 at the bottom of the page, this gets a little bit trickier, this on your own problem. Okay? So remember, the first thing you have to identify is what is the total sum. If I want to figure out what is the value of x, here in this situation, it's a little bit unique. So again, I need to know there are 1, 2, 3, 4, 5 sides. So I'm going to use that formula, n minus 2 times 180. Okay, well, the number of sides is 5. 5 minus 2 times 180. Okay, so that would be 3 times 180 altogether. So if I do 3 times 180, again, follow along with your calculator, if you multiply that, you would get 540 degrees. So that's the total. The total sum of all of those angles together is 540. So like we've been doing with triangles, again, I would try to write an equation for this, where I would say I've got 2x here plus another 2x plus all of those angle measurements I do know. Okay, 145, 145 plus 110. Altogether, that has a sum of 540 degrees. So now I've created an equation that I can solve, and I've got lots of like terms that I can combine. 2x and 2x is 4x altogether. All right, and when I add 145 plus 145 plus 110. And I know you can't see my calculator, but that's what I'm doing right now. I'm adding those, and I'm getting 400. So if you add all three of these values here, I'm getting 400. So 4x plus 400 equals 540. So now in order to solve this equation and figure out what x is, I have to subtract 400 from both sides. That leaves me with 4x remaining on the left. And on the right side of my equation, I have 140. So ultimately, to figure out what is x, I have to divide both sides by 4 using opposite operations. Division is the opposite of this multiplication here. And 140 divided by 4 is 35. So ultimately, if they ask me to figure out what is x, x in this image up here is 35. Okay? And the directions here said find the value of x. They didn't tell me to find the angle measurement, so I don't have to worry about how many degrees that is. I just had to find what x is. Okay? The last thing you want to take a look at before you start your homework is we also had a conversation about regular polygons. In a regular polygon, all sides are congruent and all the interior angles are congruent. So what that means, and often you'll see these little tick marks here, and remember on the smartboard sometimes these are a little bit distorted because the image gets kind of squished together. So sometimes you'll see these little tick marks on every side. And what that means is every side is the exact same length. Okay? That's the definition of a regular polygon. All sides are congruent. So if one side is 5 inches, they're all 5 inches. It also means all of their angles are the same. So if in this figure, I could figure out, if it's a regular polygon, I could figure out, well, what is that angle measurement? Okay, how many degrees is each of these angles? And remember, they'd all be the same. So if I take a look at the number of sides, again, I have 1, 2, 3, 4, 5, 6. You need that information first. It's a 6-sided figure, what we would call a hexagon. So using our formula, n minus 2 times 180, a 6-sided figure, 6 minus 2 times 180. So 6 minus 2 is 4. And when I multiply that by 180, I get 720. So the sum of all of these angles added together has to be 720 degrees. Well, how many angles are there? If I want to know what is the value of one angle measurement, all I have to do is to simply take that 720 degrees and divide it by 6, because there are 6 angles. Okay? And a regular hexagon would have 6 equal, or maybe I should use my math vocabulary instead of saying equal. Equal is a decent math word, but we've talked a lot about congruence lately. So 6 equal or congruent angles. So what that means is those 6 angles are all equal. So if I take 720 degrees, the total sum, and I divide it by 6, it's going to tell me the value of each of those angles, which is 120 degrees. So a hexagon, all of the angles added together equals 720 degrees. If there are 6 equal angles, each one of them is 120 degrees. This angle is 120, this angle is 120, this angle is 120, this angle is 120, this is 120, and this is 120. Okay? So that's how you can find the sum of the interior angle measures of any polygon simply by knowing the number of sides. You can also use that information to find missing angles or missing information. I hope it's helpful to have this information as you take a look at this before you get started in your homework. Good luck.